Welcome back, everybody. We are going to continue our work in Chapter 2 this week. If you recall, we were able to get through a good portion of the lecture materials last week, and where I left note that we needed to proceed was, I think we completed in our book floor division and remainder division. So you guys remember those concepts. And the next section that we need to cover is now called calling functions. So we're working on section 2.24. And I thought I'd take a different approach this time around. Rather than using the PowerPoint that comes from the author, which I think is a little cumbersome because of some of the extra stuff he throws in there, or he or she, I should say. So I'm deciding to actually work off of the book, and I do this in some of my classes for lecture. And it's not really like reading you the book, but I'm trying to hit all the highlights and get all the key concepts in place so that you guys are aware of them and the things that you might be tested on and what your homework might be based upon. All right, so we're going to pick up right here, and right from the get-go, we started using functions. In fact, the first thing you learned how to do in a Python program is to use the print function. And the print function is just simply where you use the keyword print, a set of parentheses, and then inside of it, whatever it is you're printing. If it's inside double quotes, of course, it's a string, and if it's not, then it's a number, and you can put it up on the screen. Not really a very difficult concept, but little did you know that right from the get-go, you were actually using a function that's built into the language. And this section here kind of talks about that a little bit more, because as you start to do higher level work, what you're going to discover is a lot of things that you might normally do in programming, the action has already been pre-created and is often part of what we call standard libraries for a language. And one of the examples that they're using here is the absolute function, absolute value function. All right, so you see the syntax for it here. And if you guys recall from learning math, what is the absolute value of a number? No, nobody remembers. All right. Well, let me tell you this. If I walk forward 5 steps, and let's say every time I take a step, I go a yard, right? And I'm moving in a positive direction on a number line, I just moved 5 yards. Okay? If I start walking backwards, I'm going in a negative direction. So the sign of my numbers change. I'm walking backwards 5 steps. How many yards do I cover? 5 yards, right? All right, but even though there's a negative sign in front of it, the absolute value of the number is just the value of the number without the negative sign. That's all it is. That's just a way to remove whether it's positive or negative. That's most often used when we're measuring distance or working with a Cartesian number system. That means when you're plotting it on a graph and you happen to be going in a backwards direction or a negative direction, it still covers a distance whether or not you're going negative or positive. That's the concept. So let's take these couple of examples here, and what I'm going to do this time around is I'm not going to actually build program code. Remember, in the Spider IDE, we also have this tool called the console, right? So I can actually paste stuff in here. Well, actually, it's not letting me paste. Well, I guess I have to type. What a pain that is, right? And if you remember, how they did this, they said distance equals ABS, and they put in a variable, right? But I'm going to put in a number, and I'm going to put in -11. And I run that, and I'm assuming it did it, right? Didn't give me an error message. It just took it in. Now, if I want to print, and the example they use in the book, I think, is print the absolute, or how about the distance traveled is, and I'm extrapolating here, and then I put in a comma, and then what do I put in here to make that distance show? Yeah, that's just the keyword distance, because we stored the value in the variable, and then we're putting in the parens, and then I should just be able to press enter, and now it gives me the distance without the negative sign. So that's an example, really, of using two built-in functions, one being the absolute value function, which just basically gets rid of the positive or negative sign. So that's an example of doing that. So I'm going to be doing a lot of little examples from the console like that, just simply because it gets the idea across and it just shows you how it works really fast without actually necessarily having to type in a whole program. All right. Now, they're going to show you that some functions have a certain number of parameters that they accept, so a certain number of things you can throw at it. The print thing that we just did, notice I was able to put in a string, then put in a comma, and then throw in a number. So I could actually throw multiple things at it, and I'm not really sure what the functional limitation of print is, but you can throw a lot of stuff in there and you can keep mixing it like that. Conversely, the absolute value function really only can take one number. Doesn't make sense for it to take any more than that. So sometimes you will get error messages if you're throwing too much stuff at a function that it can't handle. Doesn't know how to read it. It will throw an error message. Not that you necessarily even need to try it. There's other functions like the round function. So let's try that. So that one's just a very simple one. And I forget what the exact number was. It was something like this, right? So what would you predict is going to happen when I type this command? Let's see. It actually rounds to 8. We didn't specify how it should round, so it makes an assumption. The assumption is to round to the nearest whole number. That could be useful. It might not be. Let's say we're dealing with dollars and cents. You'll notice that the round function also has a second parameter that you can specify, which is the number of digits past the decimal point to which you need to round. If you don't list it, it assumes a whole number. Pretty simple little thing. So let's try the same thing again. And this time we'll do 7.625, comma, 2, meaning we're rounding to 2 decimal places. And now you're going to see that it rounds to 7.62. Is that what you expected? I want you to think about that for a second. If you were taught in school how to round numbers,
5 you round up.
yeah, normally you would, on 5 you round up. So this is telling you can't make that assumption here. That's kind of a whole separate little conundrum that we deal with, because some of the rounding, notice that 6.27 will go to 6.3, but 5 in this language does not.
That kind of weird. Is it because we start counting at 0?
Well, if you start counting at 0, that's a really good theory, right? If you start counting at 0, you got 0, 1, 2, 3, 4 is the 5th digit. So 5 should logically move it.
Yeah.
I want you to think about that one. Now, there's entire fields of study on this, and they have like combinations of things that you can do. But I'm not really worried about like the rounding issues at this point. But it's important to note that it might not behave in a way that you normally would anticipate. And as a programmer, you need to know how it behaves, so that if you're writing a program where you're expecting it to go a certain way, they actually adjust that, So, all right. The whole point of that really was to show you that you can run these functions. They have a couple of other ones that they throw in that might be useful for your homework. One of them is the max function, and one is the min function. And these are pretty simple little functions. So if I did a max function, and then what I'm going to put inside here is basically values, numeric values. So I'm going to put in 11, 2, 4, 7, and 24. So when I press enter, what's going to happen? That's right. So it looks through a whole list of values, and it tells me which is the greatest one. Now, I can do that on my own. Do I really need a computer to do this for me? Well, not really if you're just looking at a list of numbers. But what if it's a whole list of variables that are being calculated? In that case, it's pretty helpful, right? Because you don't want to sit there and have to do the math for every equation to figure out what the variable is. So that's kind of the why. Min, of course, is the converse of that. So it finds the smallest value in there. And you notice how how I made that appear instantly in the console? Just hit the up arrow key, folks. That's all you have to do. That's just a little tip. So you can try some of these like that. So I just typed in min, I got the lowest value there. All right, so that's what min does. All right, they have some little expressions here that you guys can play with. And moving on. All right. One of the other important things is some of the functions that we will work with are going to definitely be mathematically related. In fact, the few examples that we just did were essentially that. And I mentioned before that once we start pulling in functions, there are certain functions that are just built into the language. I don't have to do a darn thing to make them happen. I just call them and they work. However, when you are writing a program that uses higher end math functions, sometimes you have to do what's called an import statement to pull the libraries into the program and allow them to execute. So one such example would be this statement here. And this is a real common one to use, especially when we start to do higher level math. So the point is that we are saying from the math library, import the square root function. That's how you read it. Now for those of you that are concurrently learning how to do Java, and I assume if the first semester people, you're probably at this point like using a scanner in your program to read an input from the user, right? And we're about to learn the same thing in this language. So you're going to get a little bit of a correlation here. So if I want to use a math library, I have to use a statement like this at the top of my program to pull it in. All right? There are some functions where you don't need to do that. Print obviously is one of them, right? We didn't have to call anything to make that work. But as you get to higher level things, what's going to happen is you will be pulling stuff in dynamically to enable your program to do stuff that otherwise you would have to create yourself. The really cool thing is you can actually create your own libraries of functions that you can import. So if you create something that does something really cool, you can save it as a file, you can import it into your program, and draw upon all the stuff that you pre-created. So that's one of the beauties of this import thing. All major programming languages have stipulations like this. With Java, you do import statements. So Python is functionally similar to Java. In C#, when you guys learn ASP.NET programming, you'll learn that you use a using statement as opposed to an import statement. Functionally, the same difference. You're just pulling in outside resources. All right. So if we were to pull in the math module for one of our programs, in other words, we add that line of code at the top of our program, here are some of the possible math functions that are built in. And certainly some of these, like sine and cosine or something, those are not things you want to have to write from scratch. Not that you couldn't, but why would you do that when it's already created? But here are some of the common ones. And the one that's really kind of important for your homework, because one of your homework assignments is to find the distance between 2 points. And how do you do that? The Pythagorean theorem, right, which is a squared plus b squared equals c squared. In order to solve for c, you have to get the square root of it. And how do you do that if you don't know how to bring the square root in? Well, this is how you do it, folks. So at the top of your program, you would list from math, import square root. You would just copy that and take it right to your IDE. And I'm this is an example program I have up on screen right now. I would drop that in. And then if I want to actually do the math, then I could, functionally do this. Now, x is not defined, but I could define that. I could say x equals, 24. And then, of course, I could just print it. And I'm not doing anything fancy here. That's not really the point. The point is just to show you how it works. Okay? And then there's your answer. In some cases, we don't care about all those decimal places, and in some cases we do. Sometimes they're significant, sometimes they're not. All right, so those are some of the common ones that you might use. Remember, I'm not assigning any of the scientific homework to you guys. So So you guys don't have to worry about logarithms and things like that. You know, they'll all be pretty basic. They also have a neat little chart here which shows you how to convert from, you know, fancy looking, you know, calculus-like or trig-like equations to how to do it in Python, and that might be a handy little table for you. There is a way to convert everything. It's just a matter of knowing how. In some cases, you don't need the math libraries, but in the case of a square root, you do. That's a little bit higher end functionality.
Import the math, what's the, you know what it is?
I'm sorry. All right, so remember we had that issue with rounding. Here's where the author starts to address some of that. And he indicates that sometimes when you do some math, you get results that you don't anticipate. Like this first example here. So he's got a price of $4.35 on something, so that's a floating point number. And this is an integer, right? Quantity of 100. If you multiply those two out, right, it should come out to 435. But if you run a print command on it, it will actually come out to that. Now, that might make you feel a little uncomfortable because this is pretty straight up math. It should really just resolve pretty easily. But really what's happening here is that there's the math inside of Python, because we're dealing with floating point numbers, makes some extrapolations which forces that to happen. A lot of programming languages actually do this, and it's a little uncomfortable at first. So then what you need to actually do is ultimately do a rounding to correct it. Now how do you know that? Because you run through the action of doing it, you end up with a situation, and then you figure out how to fix it. That's typically what happens. People forget it, and then they have to force it to be what it is. All right, so he talks about unbalanced parentheses. You want to make sure that whenever you work with parentheses in an equation, that whenever you have one that opens, it closes. If you're not sure of how the math engine is going to evaluate your equation, like if it's going to multiply first or divide first, you can force it to do what you want just by how you place your parentheses. And that's, I think, a very important thing to know. All right, I'm moving on. All right, they have these little problem-solving sections, and I'm not going to cover this in particular because, you know, frankly, I think that you can read that on your own. So I'm going to move on to the string section, which is section 2.4. So we already learned what strings are, right? And strings are basically just a sequence of characters, and that's what it indicates right here at the top. We started at the beginning of the class doing simple little statements like this, print hello, noticing that we have double quotes inside the parentheses to indicate that it's a string, that we're treating it as a collection of characters. You can also store your strings into a variable and then print that variable. Works the same way, and that's fine. It's a real common technique, actually. All right. When we say something is a literal, when I go to do a printout of this is a string, that little part of it is what we call a string literal, because I'm not putting it in a variable. I'm literally taking that text and putting it on the screen. Okay? When I can't call something a literal is when it might change. So for example, if I'm asking the user, for example, to input their name, I can't predict what the user is going to type, so that can't be literal. That's a variable. Once it gets stored, you know, it turns into a piece of stored data. But when I'm forcing it like this is called a string literal. Another thing that we haven't talked about much is the fact that sometimes when you're working with strings, you get this option. You can work with single quotes if you want to encapsulate it, or double quotes. What happens if you want to put the double quotes up on the screen? Well, here's an example like this, where the whole statement is wrapped with single quotes. So you see the single quote right at the end there, where my pointer is? And then inside those single quotes is a separate set of double quotes. I have to alternate them like that, otherwise I can't get the ones on the inside to show. If I used all double quotes, it would think that all of what I was trying to say was he said, and it would end there, if this was also a double quote. So that's the reason why they allow for both, is so that you can put them inside of each other and nest them. I typically find that some programmers like it when you like prefer one over the other is kind of what I'm trying to say here. So like some programmers prefer single quotes and some prefer double quotes. I think the overall convention, what I've seen out in the world, is most people go to double quotes first and then single quotes only if they need it. But there really is no rule. You can go either direction. There are some functions that are built into the language that also handle things related to strings, like we have things related to numbers. So for example, here's an example of this little statement that determines the length of a string. So I'm just going to demonstrate that one real quick. And see, it didn't like my word length, did it? Or did it? I want you to think about that. They just put in the word world. And so what's the result of that? We didn't see anything happen, but it stored something in length. So now we're going to print length, and it's going to print 5. So it went in there, and it has the capability of counting how many characters there are within that string. Now that might seem like a silly function, but actually that can be quite useful when you're programming. And they have some little exercises here that demonstrate it. So I'll let you guys play with those. Another really important concept in working with strings is this concept of what we call concatenation and repetition. Now concatenation, that's a fancy word to basically say to join strings together. And often we're joining strings, but sometimes you can also join strings to numbers, but usually you have to convert those numbers to a string first before you can join them. So let's take this little example that they have here. They do Harry, Morgan, and then they add those two together and store them here and then output them. When they output them, notice that it's Harry Morgan without a space in between. You guys seeing that? But you can take the two strings and add them together, and that adding together is the concatenation part. So if you ever hear that term, concatenation, it means joining strings together. Now the fix for that is to take the first name and add to it a space, see the two double quotes with the space in between, and then add the last name in, so then when you go to print it again, now it shows the space. As a programmer, you have to be aware of that, because most users, if you prompt them for their name, they're not going to type a space in the mix. They're just going to say, Joe, last name, Smith, right? And then if you want to say a welcome message to it, you have to insert that space yourself. All right. Interesting thing is, we can use that addition sign to join strings together, but you also can use a multiplication sign, and this is kind of a unique thing, because I can't think of other languages where we do this. Usually we have to write loops or something to make this happen, so this is kind of a neat little feature. So if I wanted to create a line of dashes like this, I can actually put in there a dash instead of double quotes, multiply it by 50, and then store it. And it allows you to do it, and I think it's brilliant. It is so dumb, but so cool at the same time.
I've literally been breaking, I count them out.
Yeah.
A couple on the assignments.
Right. Some of the assignments, right, where you're like creating letters and stuff and you're manually counting it out. And now they're showing you the shortcut, right? All right, so here's like the way that you can do that. Another example of the same thing, where you have a message, right, and you store that message, echo with 3 dots, and you put it in this message. I can also do that multiplication right inside of a print command, so I can just take the message and multiply it by 5, and that will display this. So that can be just a useful little trick. Very, very simple little examples, but kind of fun at the same time. All right. One of the conundrums that we enter into as programmers is how do we switch from numbers to strings and do it in kind of an elegant way? And you know what? It's a little odd at first because it's kind of a mechanical process. There's really kind of no shortcuts to this. So for example here, and we tried to do this in like early weeks, if you remember, like we had print statements, and I was trying to use like a Java approach, right? Like, so if I had a Java like system out print line, right, and that might sound familiar for you Java people, I can take a string and I concatenate a number to it, and it'll work. It doesn't work that way with print. So here, they're trying to do the same thing and then store it in a variable. That still won't work. It's not allowed because there's what we call a type mismatch. They're not the same kind of data type, so you can't functionally join them together. So most languages will have these tools or built-in functions for converting things first to a string. So notice, if I take string, the string function, it's just str, and then inside of parentheses, the number, that will convert it to a string. So numbers are characters also. That's another kind of lesson here. So a string of characters that are numbers. Now, I can't do math with those numbers. You got to keep that in mind. Once I convert it to a string, math is off the table. However, I can do stuff like this. So a real common thing is I might ask a user, what's your ID? They type it in. We store it in an ID variable. And then when it comes to concatenating them together, I know that this is a number, so I just put the string in front of it. Now I can concatenate those two, so that would result in agent 1729 as a string. And then I could put that up on the screen without a problem. That's concatenation and converting. So in this case, converting from a number into a string. Now sometimes you want to go the other direction, because when you grab stuff from the keyboard, and this is the bizarre part, whenever you're interfacing with your user, on the screen, they're typing in characters even if they're numbers. So when we're grabbing it from the screen, we will put in front of it the little integer thing that's going to convert the text of 1729 to a number which I can then do math with, or whatever I'm going to do with it. Same thing is true if I want to do floating point numbers. So if I wanted to say, if I had this string and I want to convert it to a floating point number, I just put the float command in front of it, or the float function is basically what that is. One little tip that they're giving you is you can't do math inside of there. You have to take the value and convert it. You can't do the math and convert from there. Because this, being a character functionally here, it's not going to execute, right? Because it's inside of a string. If I do math separately and store it in a variable and then convert it, that would be okay. All right. All right, a few more helpful tips there. Moving on. All right. All right. Another thing you're going to learn about strings, and I think, in the Java language, it becomes a little more apparent than it does here. Strings in Java are actually a class, if you guys are learning Java concurrently with this. And technically in this language they are too, but really when you think of like what a string is, it's a string of characters put together. So anybody's name is a collection of the letters that makes up that name. When you put together a string, there's an implied like data structure here that I just zoomed in on a little bit to make it a little more visible. So if I have the name Harry, we can count the positions of each of the letters. Notice where the count starts. The count starts with 0, right? So H is in position 0, A is in position 1, R is in position 2, and 3, and Y is in position 4. Now the neat thing about that allows us to actually go through and individualize what we're looking at in the string. So I can actually pick out a particular letter in a string to focus on. So for example, if I put in the variable name, the string Harry, and then I run this, right? And I'm not really running it. It's a syntax basically. I say name square brackets 0, it will go to position 0 and read that into the variable. So first would become what? H, right? Here, name goes to position 4, which is the 5th letter, 0, 1, 2, 3, 4, right? And it would pull in Y, so last would be Y. So first is H and last is Y. So some of you may have seen this before. Another real helpful thing, right, and we talked about this, is that length thing. So why would you measure the length of a name to know how many letters are in it, right? That's why. But the funny thing is if I run length, what's the output? And notice that it's going to give me, if I ran that, it would say 5. But it wouldn't give me the position of the last letter. So if I went to like position 5, it wouldn't even exist in Harry. So in order to get to that last position, you subtract 1. So often when you're dealing with these, what we call array structures, where we have index values that start with 0, sometimes you'll see people doing length minus 1 to be able to get to the last position. Or to switch it to the counting number that we're used to. Because what we're used to is Harry would start with H in the first position, right? So that starting with 0 can throw people off a little bit. All right, moving on. There's a number of different methods that we can apply to strings. And, you know, they start talking about what objects are, and I'm not really too worried about you wrapping your head around that yet, because you'll get that in your Java class probably before you get it here. But whenever you have an object that you're dealing with, and a string is a type of object, you typically will have methods that are associated to it that allow you to do those extra things. So here's an example of how we can apply some of those methods that are built into the string object, as you see here below. So here they're taking the name John Smith as text and storing it in a variable called name. Okay. On the next line, they're taking name, which is our stored value, and then they're adding to it a dot. And this is called dot syntax, by the way. And then they're putting in a function call. We know it's a function call because it has parentheses after it. It tells us it's a built-in function. It's built right into the string object, which is automatically part of the Python language. So if I want to take that name and convert it to all uppercase, I would issue this command. I would just say name.upper, empty parens. It takes it and switches it to uppercase. As you would anticipate, you can also do it with lower. And here it also shows you that you could do that dynamically by just throwing it directly into a print command. It would make everything lowercase automatically. Another thing that you might want to do is take a string of text and replace it with something else. So in this example, when I call the replace function, in the first spot, I take what it originally was, and in the second spot, what I am changing it to. And I want you to notice, this is kind of interesting because name is the whole name, John Smith, right? Here, we're switching John to Jane, and it's only changing John to Jane. It's not touching Smith. So I'm able to go in there and alter a string dynamically with that command. First part of it is what it was. The second part of it is what it's going to be. Yes, David?
If you want to change the whole name, would you write John Smith?
Yes, you would.
And then comma to what James, James.
Exactly. Yeah, or whatever other name you wanted. Yeah,
right.
That's correct. Because this will go in and selectively replace part of it. So those are 3 methods that you'll find pretty useful for doing your homework once again. And I'm moving on. All right. Another thing that's kind of fascinating here, and I don't want to take too much of a sideline on this, but when you learn that all of these characters that we work with are based on what we call ASCII Key Codes, and I'm pulling it up on a separate tab on purpose because they have like entire charts here that show you the key codes. Like, so any of the letters that you would, or numbers that you would press on the keyboard, and what it converts to in forms of key codes. Now they have this in an appendix in the book, but what they're trying to show you is that any of the letters that you create also has a character value or a number that's associated with it. Now why that's useful is, for English letters it doesn't really matter so much. But when you're trying to get in like that umlaut, you're working with like German, or that accent if you're working with Spanish, there's special key codes you need to know to be able to make those happen. I'm not really too worried about focusing on that. If you ever get into that level of programming, believe me, you'll learn this chart. Nothing you would ever memorize, but it is something that can be helpful at times. Another thing that's kind of important to know is sometimes you need to actually put characters in a string that you can't normally force in. So for example, if I'm working inside of an environment where I need to mix my single quotes and double quotes together, and here's an example. They have "you're welcome," and you notice that's a single quote. So just because that's a single quote, the outside ones have to be doubles. But for whatever reason, this person also wants to get the word welcome in there with double quotes in, and the only way you can, make that happen is to put a backslash in front of it, in front of the character, to force it to display. That's called an escape character, and so when you see that like this in code, that means they're just trying to get that double quote to show up in the string without breaking the string. So they put the escape sequence in to allow it to render, and then they put another one here to allow another one to render. So both of those double quotes will show up. Another one that's kind of tricky is this one, right? If you're writing like a Windows directory tree structure or whatever, and I know there's some assignment in the book, and I opted not to assign it to you guys, where they have you like print like a path like this, and the only way you can get the backslash to show up is by putting a backslash in front of it. Otherwise, it assumes it's an escape sequence, right? So if you want a backslash in your string, you got to use two of them. One that is kind of helpful, though, that you might find a lot of use for is the new line character, which is a /n. And this is true in a lot of languages that we can do this. And that's also an escape sequence, but what it allows us to do is to create a new line for our text without issuing multiple print commands. So what they have right above my pointer here, which is a star, /n for a new line, 2 stars, /n for another new line, prints what you see here. 1 star, 2 star, 3 stars. The /n makes it possible. So I find that one particularly useful out of all of them. Usually, if I run into situations like this one where like "you're welcome," I might look for a different way to do it before I put escape sequences in. Frankly, as a programmer, that's what I would probably do. But there are circumstances where you kind of need to do it, so that's why it's important to know. All right. They go through a nice little thing here about input and output and talking about character codes, and it's a good read, so I suggest that you do read it if you get a chance. I'm not going to cover it here in class, though. All right, now we're getting to one of the important parts for doing our homework, and that is dealing with input and output. And most notably, being able to prompt our user and get a value from the keyboard that we can use in our program. That's a real common thing to do in programming. So when we are getting input from our user, that's called a prompt, right? So even to this day, if I bring up a command line screen, and I end up looking at this, took a while to load. Well, I guess I did it more than once, huh? That's called a prompt to this day. And what is it doing? It's just sitting there waiting for me to type a command in. So I'm being prompted right now to do something by that flashing cursor. That's called a prompt. All right, so notice how that we do this in Python. First, you need to put a message on the screen. And here we actually run a function called input. So this is what's going to grab whatever the user types in. So we say input, and then in parentheses, what's the message you're sending to the user to do whatever they're doing. Okay, so this one's pretty clear. It says, enter your first name. And then logically, we're placing it into a variable called first. And that's a real common thing you're going to see as well. Typically, you're not going to prompt somebody to put in information and not have somewhere to put it. So almost always, you're going to have something on the left-hand side of that equal sign. And remember, that is not a math equal sign. That's an assignment statement. That's what we call it, an assignment statement. So whatever's on the right side of that equal sign is going to get stored in whatever's on the left side of the equal sign. And if you're getting input from your user, it's really common to have a place to put it. This is actually a very clean approach. So if this command would actually yield this output, and then, of course, it would wait for you to type something, and then you type it. All right? Then that will get stored. All right? Now, what's kind of nice here is, if you look at this little program. You know what? And the beauty of this is we can actually run this, right? If we wanted to, because they have a little run button here. But notice that this program gets one input, says enter your first name, puts it in first. And then it says enter your significant other's first name, your wife, your girlfriend, whatever, and store it in second. And then we run this series of commands. And notice what they're doing here. This is kind of interesting, right? So they have that square bracket approach. So we go to the first string that we have, and we're looking at position 0. What's that? That's the first letter of their name, right? So we're going to grab, in this case, Sally, right? Because that's what our first input is. And then from the second one, we're going to grab H, or Harry, because that's also position 0, or the first position. And then we're going to put an ampersand in between. So this is just a really sweet way of Sally and Harry putting their initials out there, right? That's what's happening here. And then ultimately, those are getting concatenated together, stored in a variable, and then being output. You want to try that one? It's pretty easy. You can always grab, remember, you can always grab this code if you want, and drop it right into your Spider IDE and try it if you're curious. You can always run it right in place there as well. All right. Now we got to deal with the fact that sometimes when we ask users for input, the input has to be a number. All right. So I'm going to do a comparison once again to Java because I know some of you are taking that class concurrently. In Java, what we do is when we grab an input from the user, we also tell it what kind of input we're expecting, right? So if you're expecting an integer, there's like a little thing for integer. If you're expecting a double, there's a little thing for double, right? Okay, I'm assuming you guys are all nodding and smiling. That's my self-amusement there, frankly. But let's take a look at an example where we're asking the user for a number. So here, we're setting up a variable to hold the value, whatever we grab from the keyboard, and we put out the input function, and we say, please enter the number of bottles. Now, it's a fairly safe assumption that they're not going to say 3.5, right? So we assume it's going to be an integer. So we grab whatever they type, and we store it here. This part of it doesn't care if it's a number or not, okay? However, we know that when we're capturing anything from the keyboard, it's coming in as what? Characters. So that means if we want to do any math with it, we have to convert it. So after we've grabbed the user input, we then run the integer function to switch it to a counting number and then store it inside of bottles. So that's something that's necessary in these types of programs. And they have this little graphic here which I think is pretty useful. But that's a real common thing. Now, my advice to you is to use the same technique that you use in Java. In Java, when we ask people for input and we run the scanner command and we grab it from the keyboard, we typically on the very next line are converting it to the number it needs to be. So in Python, they recommend that you do exactly the same thing, because otherwise, guess what happens? You forget. And then when you forget, your programs get screwed up. All right, so here we are going ahead and we are grabbing the number of bottles. They come in as a string, then we convert that string to an actual number to store in bottles. That's just the typical pattern. All right. Not too much more left here. You guys are probably breathing a sigh of relief, I'm sure. This is the last section we're going to talk about in this chapter formally, and that is formatting output. So one issue we run into is sometimes when we're trying to output numbers and or words, but it seems to be more of an issue with numbers, we often need to display them a certain way because of whatever we're doing. So for example, if we were trying to determine the price per liter of like gasoline or soda or whatever it is, having this output is not particularly useful unless you really, want to know the, 1/1,000,000th of a penny that you're spending on this. I guess if that's significant to you, that's great. But I like it when I go to certain grocery stores, and I think a Woodman's is one of them, where you look at like your stuff on the shelf and you try to figure out, do I buy this one, it's on sale, or do I buy that one? And they break it down to price per ounce. And then you can do a comparison and say, well, this cheese is 23 cents per ounce, and that cheese is 24 cents per ounce. But the 24 cents per ounce cheese rules, and the 20, that kind of thing. It just helps you with decision. So if you were to do some math, you might actually calculate that the price per liter is something messy like this, but that's not useful to you. So what you need to do is learn how to use what they call print formatting. This is also something you can do in Java and other languages, frankly. JavaScript does it as well. And they have these like formatting commands that you can use. Now when you see here, this declares actually a pattern of the format, that first part of it. And then this little mod symbol, right? But it's not really doing math here. It's just indicating what are we formatting. We're formatting the variable of price. The format what we're going to use is, well, anything before the decimal point doesn't matter. That's what the percent means. It's a variable. It's a wildcard. After the decimal point, we want 2 characters, and the F indicates we want it formatted that way. So 2 characters and then stop. And so then we can take this value here, and it will print out 1.22. I want you also to notice that it seems to be rounding it correctly too at the same time. There's a little bit of rounding that happens with that function as well. Yes, David?
So what's the difference between this and the actual rounding?
Well, the round command just does the math. This is designated only for screen output. Okay? So whatever this is putting on the screen doesn't mean that that's changing the math in the background.
Right.
That's the difference. So we, in the variable, we're still storing all this detail, but in the output, the user sees this, but we're not changing the variable. There's a bunch of different formatting things you can do here. On this example, this one actually forces a total of 10 characters on the left side of the decimal point. So that just gives you a little bit of an example. There's a bunch of little tips here in this graphic if you guys want to indicate it. And you know what? The fascinating thing about this is you can really ramp it up to kind of like a ridiculous degree because they allow you to do multiple layers of this formatting. So in the first examples, we were just looking at numbers, but there's other ones that you can do to also format text at the same time, which can be, I think, kind of useful. And you follow the examples here to do it. So they have a little table here that I think might help you with some of the homework that relates to this, or if you just want to make it look nicer, this is what you do. In many cases when I teach programming, if you get the number and you can display the number, I'm usually pretty happy with that, unless I'm asking you format it in dollars and cents. Some examples in a lot of programming courses, you might be asked in one step to calculate the value, and then the next step to actually format it to something that a user could use. My line of thinking is you should always think about the user when you're creating stuff and putting it on the screen, Because if it's not useful to you, it's probably not useful to them. If there's some reason to look at like the 50th decimal place, well, then put it on the screen, right? If you're doing like scientific calculation. If not, why would you do it? It doesn't make any sense. You don't want to scare your users away. But follow this table to help you do the formatting. Most languages have these types of formatting tables, and it's just kind of interesting to note. All right, folks, that's going to end the lecture component. There is a section in this chapter on graphics, but the other instructors and I have decided that that's not something we're going to really focus on a lot in this course, just simply because of time, because that's really kind of a whole separate field of study. But if you're interested in it, please explore. In fact, I will on occasion give you extra credit assignments that will focus on those. All right, this video ends here, folks.